Welcome to EPG Pathshala lecture series in computer science. This course is on operating systems, and in this module we learn details about file system interface. The learning objectives of this module are to explain the uses of files and file systems, to learn different attributes and different types of files, to understand different file operations that can be executed on files, and to discuss about the different file access methods. So, information are stored in different storage media. For example, you can have disks, you can have magnetic tapes and different other storage media in which you can store information. And when you are looking at a disk, data can be stored in small units called disk blocks, or the disk is logically divided into disk blocks in which data is being stored. But the users need not be aware of this. The users need not know that the information of users are stored in disk blocks, and it is enough for the user to understand information in terms of files. So, the OS defines a logical storage unit which is called a file. So, the user will look at information as files, but these files in turn are stored in disk blocks in the disk. So, the mapping of the files into the physical devices or into the disk blocks in the disk is done by the operating system. And these physical devices like the disk and the magnetic tape, they are all non-volatile. And what is a file? A file is a collection of related information that is stored in the secondary storage device, and it is the smallest allotment that can be stored in the secondary storage device. And these files, they can represent programs, or it can be data. The programs can be, say, source programs, or it can be object programs, or the files can have executable information, or it can have, say, audio, video, or it can have data files. The data files can be numeric data, or it can be alphabetic data, or it can be alphanumeric, or it can be binary, and so on. So, different kinds of information can be stored in files. So, when you look at the structure of a file, each file has got a defined structure, and that depends on the type of the file. Say, for example, if you look at a text file, the text file is a sequence of characters which is organized into lines. And if you look at a source file, it will have a source program, and it is a sequence of subroutines and functions which are organized as declarations, then followed by executable statements. Or a file can be an object file. In an object file, you can have a sequence of bytes, and these are all organized into blocks, and it will be in a format that is understandable by the linker. Or the file can be an executable file, where you have a series of code sections that the loader can load into the memory and execute. So, what is a file system? So, when you have a collection of files, it is called a file system. When you have a number of files, these files are stored in the secondary storage device, say for example the disk. But if there are many number of files, and you may not know where the file is being stored in the secondary storage device. When the files, say you have thousands of files and so on. So, you need to have some way in which the files are organized, or they are organized into a particular structure. And thus this file system came into existence, and the file system is nothing but a collection of files, and many files can be organized, and similar kind of files maybe you can put under a particular directory, and you can have many such directories, and all these form a directory structure. And many directories can again be put under another directory, and so on. Thus, it can form a hierarchical structure, and it is called a file system. And if the disk is very large, it is also possible to divide the disk into multiple partitions. You can have the disk divided physically or logically into a separate large collection of directories. It is also possible to place different types of file systems in different partitions in a particular disk. So, now we will see what are the attributes of a file. One attribute is the name of the file. This is an attribute which we all know, which we all see in a particular file. So, this is the information that is kept in human readable form, and each file is assigned a file name. Then you have type of the file. So, when you have systems that can support different types of files, each type of file is identified using a different extension. Say for example, we have machines where we store say .txt, a text file, or .doc, which is a word file, or you can have .xls and so on. There are different types of files, and this is needed for systems that support different types of files. And location, where is the file stored in the secondary storage device? As we all know, files are stored in the secondary storage devices. So, to access the contents of a file, we need to know where the file is stored in the secondary storage device. So, location information of a file is also an attribute of a file. Then you have the size of the file. Then protection information. So, a file can have different access permissions. Say you can have a file which can be used only for reading by certain people, and certain other people can use a file for writing, certain other people can use a file for executing, or you can have a combination of these permissions that are assigned for different people. So, based on that you can have different protection rights for different people. So, protection rights are also attributes of a particular file. Then the time of access, date of access, the user's identification, all these information are also attributes. So, when a file was created, the time when it was created, the time when it was last modified, the time when it was last accessed, etc. and so on, all these information are kept as attributes for the particular file. And you also have different data that are useful for protection, security and monitoring the usage of the file. And where are all these information kept? We saw a number of attributes for a file like the name, the size, the location, etc. and so on, and all these attributes are generally kept in the directory structure, and this directory structure is maintained in the disk. And now we will see the different operations that can be performed on a file. The operating system provides a number of system calls to create a file, write into a file, read from a file, reposition the current place from where you will do the next read or write, delete the contents of a file, truncate the contents of a file and so on. And we will see how each of these operations are being implemented. First, we will see this create operation. The create operation is used to allocate space for a file and to create a new file, and for this first you need to find space for that file in the disk, and once there is space for that file, then an entry has to be created in the directory or in the parent directory of that particular file. So, what entry is created? The entry that we see in directories will generally have the name of the file. In addition to the name of the file, the directory entry will also store other information like the location of the file, the time of use, etc. and so on. And then writing operation. So, once a file is created, initially there will be no contents in the file, only a name is being assigned, the size will generally be 0, then the user can write into the file. So, for writing to the file, the system will first search the directory and will find out where the location of the file is. So, once the location of the file in the disk is known, the user can write the contents into that particular location. But the user need not specifically know where the location is, that will be taken care of by the operating system. So, the OS will search the directory and it will find the location of the file. Then the system will keep a write pointer to the location in the file where the next write has to take place. Initially, when the file is created, the location where the file will write will be the beginning of the file. And suppose if it had written some amount of data, then the location where the last write was done will be saved. So, the next time write happens, it will continue in the place where it wrote last. And this after writing contents into a file, the write pointer will be updated. Then the read operation. So, similar to this write operation, for the read operation also it is necessary to know the location of where the contents of the file is present in the disk. So, the system call will specify the name of the file and it will specify where the next block must be put. So, the system will have to maintain a read pointer to the location of the file where the next read is to take place. And based on that location, reading will take place, and after reading is done, the read pointer will be updated. Say you are reading say 100 bytes from a file, after reading the read pointer will be updated as 100. And for this read pointer is specific for each and every process. So, each process will have a current file position pointer, and only from that position the next read or write can take place. Then repositioning operation. As we saw for the read and the write operations, say after writing some 100 bytes, the read pointer will be after 100 bytes. So, the next time the read happens, it will happen at the after 100 bytes. Similarly, when you are writing also, say if you are written say 200 bytes, the pointer will point after 200 bytes. So, the next time you write, it will write after that 200 bytes. But if you need the pointer, the file pointer to be moved somewhere else, not at the current position, if you want to move it to another place, another position which is not the current position, then you can make use of this repositioning of the file pointer within the file. So, for repositioning, the directory is searched for the appropriate entry and the current file position which will be set to the new given value. So, it will have already it will have a value where it had operated earlier, but now since you want to change the file position to something else, it will be set to the new value. So, here no IO is needed. Actually, when the file repositioning within the file is done, nothing is changed within the contents of the file in the disk. Only the place from where you want to read or write next, which is maintained in the directory structure, is modified. Only that value is modified. No change is done to the file's contents which is placed in the disk. Then the delete operation. For deleting the operation, you will be given the name of a file and the name of the file will be searched in the file directory, and if file blocks are allocated or disk blocks are allocated to the file, all those disk blocks allocated to the file will be freed and the entry for that file that was made in the directory will be erased. So, when the file was created, an entry was made in the directory for that particular file. So, when the file is deleted, that entry will be removed. Truncating. Truncating is not deleting the file. The file's name and all will not be removed, but only the contents of the files will be released and the size of the file will come down to 0. So, for this what is done is that the length of the file or the size of the file will be reset to 0 and the space that was allocated for the file, that is the disk blocks in the disk that were allocated for the file, will be released or will be freed. The next operation is append operation. For append operation, new information will be added to the end of the file, and so for that you need to know the end of the file. So, size of the file, if you know the size of the file, current size of the file, you know the end of the file, and from the end of the file you can write information into the file. And you also have file operations like renaming the file, where the original name of the file will be modified. So, which means that the directory's entry will have to be modified. So, the original name will have to be removed and a new name will have to be entered in the directory's entry. And then you have this copy operation. Copying is, you have an already existing file. Now, you need to create a new file and copy the contents of the old file into the new file. And then get and set attributes. There are a number of attributes for a file, as we have seen, like the size of the file, like the owner of the file, the time of access, the access permissions for the file, etc. and so on. And these attributes can be got or can be viewed by the user, and different attributes also can be set by the user. So, there are operations or there are calls that are provided for doing all these. And file operations are needed for searching in a directory. See, any entry that you make in the directory, you have different entries made in the directory when you create a file, and if you want to search for a particular file, you will have to search through the directory to get that particular file. So, file operations for searching the directory are also provided. And if you want to reduce this searching a directory each and every time, say for each read and for each write, if just the name of the file is given, you will have to search for that name of the file within the contents of the directory and get the location of that particular file in the disk, and then you will have to read or you will have to write and so on. You can avoid this by making use of open and close. That is, before reading from a file or writing into a file, first you need to open the file, open the contents of the file, and then you have to do this read and write operation, and then you have to finally close this file. So, generally this open system call is used before any other operation like read or write, etc. and so on. So, this open call will create an entry in a table called the open file table that is maintained by the operating system. And after that, whenever file operations are requested, you have to just look into this open file table, and you do not have to search through the directory. After finishing all these operations, when the file is closed, the file is closed, the file will no more be used, and hence you will close the file, and then in that case the entry in the open file table will be removed. And during the first reference to a file or during the open system call, the file is implicitly opened, and when the process terminates, and even if the file is opened, when the process terminates or during a close system call, the file is automatically closed. Now, we will see this is the general syntax for any open call. It will take the file name and the access mode, that is the mode in which you want to open the file, like if you want to open the file for reading or writing or read and write, etc. and so on. So, you can specify that as well when the file is being opened. And this open system call will first search the directory, and it will copy that entry in the directory into the file table. And the open will generally return a pointer to this entry in the open file table that has been created. And after that, for further file operations, the pointer is not used, only the open file pointer is used and not the file name. And if you have multiple users that are using a particular system, then it is possible that many users can open the file at the same time. Say for example, in Unix, what is done is a per process user file descriptor table is maintained. That is, each process will have a user file descriptor table, and there is a system wide file table. So, for the whole system there is one single file table. So, for each process there is a user file descriptor table, and the whole system has got a file table. And whenever a file is opened by a process, an entry is created in the user file descriptor table. And for each file that is open in the system, there is an entry in the file table. Now, look at this diagram. Say you have process A. Process A has got its own user file descriptor table. There is another process B also has got its own user file descriptor table. There is a file table. This file table is a single table. There is a system wide table that is common to all the processes. And in the case of Unix, each file has got something called an inode. This inode has got information about all the attributes of a file. Say for example, details about the file are maintained in the inode for that particular file. So, what are the details that are maintained? The details will be like the owner of the file, the size of the file, the access permissions for that file, the time of access for that particular file, etc., and so on, the size of the file and so on. You have the different attributes of the file, information about the attributes of the file being maintained in this inode. And there is an inode table corresponding to each and every inode. Now, suppose this process A, it opens a file, and then in that case an entry will be made in this user file descriptor table for process A, and that entry will point to an entry in the file table corresponding to this particular file, say F1, and that will point to an entry in the inode table corresponding to that particular file F1. And this inode will also have information about the location in the disk where the contents of the file have been stored. Suppose process B also opens the same file F1. So, process B has got its own user file descriptor table, and an entry will be created in the user file descriptor table for process B. That will point to an entry in the file table, and that in turn will point to the same entry in the inode table, because this points to the same entry in the inode table because it is the same file. F1 is the file that is opened by A as well as by B, and hence you have the pointer, that the pointers from the file table pointing to the same entry in the inode table. It is a single inode, because details about this file F1 will be stored in a particular inode, and it points to that entry in the inode table. But you can see here that the file table has got different entries. The inode table entry is the same for both the files, and the user file descriptor table entries are also different for each of the processes. So, as I told you, the inode table has information about the physical location of the file or the disk blocks where the contents of the file are stored in the disk. And there is a count that is maintained in the inode table, which is called an open count. This count will have the number of processes that have opened that file. In the example that we saw just now, there are two processes A and B which had opened the same file. So, there will be a count which has got a value of 2 that is maintained in the inode table, which says that there are two processes that have opened that particular file. And when, say, process A is closing that file, the count will be decremented. The count in the inode table will be decremented, and it will come to 1. And when process B also closes that particular file, the count again will be decremented and the count will come down to 0. See, here you can see that process A and process B have opened file F1, and file table has got information about how this process A has opened or how process B has opened that file. Say, for example, if process A has opened F1 in read only pattern, or it has opened the file for only reading, and process B has opened the file only for writing, and a pointer will be maintained here. This is the file pointer that is being maintained for process A, and you also have the file pointer that is maintained for process B. And based on this pointer only the next read or write can happen for a particular file. So, for process B, the next time it writes, that it depends on the pointer value that you have here, the file pointer value that you have here, only at that position the writing will happen the next time. And A has opened for reading. So, the next time, say A wants to read, it will happen only at this pointer position that is maintained by this read write pointer. And since both the entries in the file table are pointing to the same entry in the inode table, the count here is maintained as 2, saying that 2 processes have opened this particular file. Suppose process A has closed, process B has closed the file, then in that case this count here will be decremented from 2 to 1, and its entry in the file table will be removed, and the entry in the UFT table will also be, the pointer from here to the file table will also be removed. Suppose if process A also closes the particular file, then the count here will become 0, and here the pointer from the file table to the inode table will be removed, the pointer from the EOFD table to the file table will also be removed. So, if the count becomes 0, this entry also can be removed from the inode table. So, thus we have seen how opening and closing and reading and writing can be done using this user file descriptor table, file table and inode table. Now, coming to the next aspect related to files, there are different types of files that are supported in different systems. Say it can have executable files, and it can have different types of extensions like exe.com, etc. and so on. So, you can have object files, you can have source code. If it is a source code, then depending on the type of language that is being used, the extensions will be different. You will have a .c or a .cc or .java, etc. and so on, different types of extensions based on the different languages. You can have a batch file where the extension can be .bat, or you can have a text file, you can have word processor files, you can have library files, you can have files which you can zip together, or you can compress and you can maintain, or you can have archive files, you can have multimedia files, etc. and so on. So, there are different types of files that are supported by different systems. So, to differentiate between the different types, different extensions are given. Now, we learn different file access methods, that is, files are stored in disk. So, different ways in which you can access the files. What are the different ways in which you can access the files? So, file information stored in files have to be accessed, and different methods are available for accessing the files. Some systems they support only one method, but some other systems they support multiple methods. So, the different methods that we will see here are sequential access, direct access and indexed sequential access. The sequential access is the most common one, where you can access the contents of the files only in sequence, that is one record after another. So, the operations will look something like, say, read the next record or write into the next record, or you can have a reset which will reset back to the original or the initial position. So, look at this diagram. You can have the beginning of a file, or currently maybe you are in this position, the current position is shown where you can read or write the file. So, you can just read, you can have a read next operation, or you can have a write next operation. That is how you can move, or you can just rewind back to the beginning, reset back or rewind back to the beginning of the file. So, this access is only sequential, one record after the another. In random, you cannot move to any disk block or access any disk block or any record. The next type of access is direct access. This is based on the disk model of a file. So, we saw that the contents of files are stored in disk blocks in the disk. So, if you want to access any block or any record in the disk, you should be allowed random access. So, you should be allowed to access the nth record or the nth disk block in the disk. So, direct access will allow arbitrary blocks to be read and written. So, you can generally say read the nth block or write the nth block, or you can say position to the nth block, and then from there you can read next, you can write next, you can rewrite to the nth disk block and so on. So, what is this n? N is a block number which is relative to the beginning of the file. So, the beginning of the file is taken as block number 0, and from there you can position to say the nth disk block. So, if you want to simulate sequential access on a direct access file, then reset is very similar to moving the current pointer from where you are reading to 0. So, if the current pointer is moved to 0, then it is similar to reset in sequential access. If you want to read the next block in sequential access, that is very similarly you can do that in direct access, like read the current position, and then from the current position you increment the current position to current position plus 1. Similarly, for writing also, writing the next is write the current position and then increment from current position to current position plus 1. So, you can simulate sequential access also on a direct access file, but direct access cannot be simulated on a sequential access file. It is also possible to have other access methods. One is to have an indexed kind of an access, where you build an index which will have pointer to various blocks, and this index will give details about the different blocks in which the file's contents are being stored. So, to find a record, or to you need to just search the index, use a pointer to access the file, and then the desired record. So, you just have to search through the index to find the contents of the file, or to locate the contents of a file. But when the file size becomes very large, say if the number of blocks in which the file is being stored is very large, you have more number of blocks in which the file is being stored, then in that case the index file also will become very large. So, you may have to provide another index for this index file. So, you can have a primary index file which will have pointers to the secondary index files, and the secondary index files in turn can point to different blocks. So, this is an example that is shown. You can have an index file which has the logical record number, which in turn points to the record in the file. So, the summary of the information that you had learnt in this class are: we learnt what is meant by a file. A file is nothing but a basic unit of storage in the disk, and the disk is logically divided into disk blocks, and the contents of the file are stored in disk blocks in the disk. A file can have a number of attributes, a number of operations can be performed on files. There are different types of files, and it is possible to access the files using different methods. We saw the sequential access, the direct access, and the indexed sequential access. References. Thank you.